Alrighty guys, so we're looking at the trapezoidal rule. The formula in question is this is the area equals h over 2. And then we have first line plus last line. So this formula is the main thing you need to know. And what we'll see is, in a few examples, this h often is either the base or the height, depending on the question. And your df and dl are going to be the two side lines, two side lines. Now, if we were to look at an example here, I will get a trapezium here, and say I've got this is nice little 5 centimeters here, and then I'm going to draw, let's say it's 8 centimeters in length. And 6 centimeters. And with this one, let's just say it curves in like that. So effectively with this rule, what we're doing is we're approximating the space or the area here, which is what we want. Now, I said this was 6 centimeters, and this is 8 centimeters, okay? And using this rule, we can effectively estimate the rough size. When you put a line through it, you can see it's not going to be completely accurate, but effectively we're estimating the size within there. So what we do is first is we go to our formula. We are looking for area. We have h, or 5. So that becomes 5 over 2. We bracket is going to be at times, and it doesn't really matter which one you choose. We'll go 6 centimeters plus 8 centimeters. All right. You put that into your calculator, and you will get 5 over 2 times 6 plus 8 is 35 centimeters squared. And so that would be the answer for this first part. Now, if you were asked to use this rule more than once, or to apply it more than once, that's referring to effectively putting more triangles underneath the shape to make it more accurate. For instance, you could if you put a line down through here, and then we had the distance here, now it's going to start being a bit more accurate, and so on. And you could just keep going and adding more lines. And if you have the distance there, you're now going to be finding the area of the trapezium here. And you can see, as I'm drawing these lines through, that it's going to be a lot more accurate to what the actual curve is, the more lines you add into it. Let's just do a nice basic one. So say we want to do just one line. We're going to have a nice line here, 6 centimeters. And then we're going to have one up here. Let's make that, I'll go 4 centimeters. I'm going to go one here as well. Oh, that's 6 centimeters. And try and find the midpoint. And that one will be about, that one will be about, so that's 7 centimeters, 4 centimeters, 6 centimeters, and each of these angles here add up to 6, but it's 3 individually. Now, maybe the curve goes up like this, and it comes down like that. Yeah, that's a bit drastic, but that's okay. You'll get the point. Now, looking at this, what we have is, going back to the formula, A equals h over 2 df plus dl. We now have two different shapes that we can work through. So let's do the first shape. So the first one, looking at this, our h is going to be 3 divided by 2. df, first line will do 4 plus 7. And when you calculate all of that together, you get 16.5 centimeters squared. And for the second shape, similarly, 3 divided by 2, close brackets. And we do our first line, so we can just do 7 plus 6. Doesn't really matter the order you do it in. And it's going to be 19.5 centimeters squared. Now, add those together, and you get your total area, which will be 36 centimeters squared. So in this example, let's say you were asked to find the area under the curved line. So in this example, we need to find the area down there. And let's say you were asked to use 2 applications of the trapezoidal rule. So if we're asked to use that, what we are effectively being asked to use is use the rule 2 times. And the easiest way to do 2 times would be to split this in half and make 2 different trapeziums. So this one, 0 to 5, we now mark where the center of it is going to be, and then we can just draw a nice line down the middle, like so. There we go. So now we have 2 different shapes. And what's interesting about this is we are actually effectively splitting it apart into 2 different trapeziums, and we're going from what we're covering from there up to about here. So it's very much a rough estimate, this, but what it is it's a nice quick way of just estimating the rough space. And the more applications you use, so the more trapeziums, the more that we're working into it, the more accurate it'll be, because then you could be doing it into each different one. Now, for this example, what we're going to do is we now need to find using the formula, find each of the different sizes in here. So our first up, the formula is A h over 2, your first line plus your last line. So let's do shape number 1. Shape number 1 will be area equals, now h is going to be 1, 2, 3, 4, 5. It's going to be 5 over 2. Our first line, df, is going to be measured here, and notice that there isn't any distance here. This is the starting point, so it's actually going to be a 0 in this example. And that can be true. And then we're going to count up this one for our last line, which is 1, 2, 3, 4, 5, 6, 7. 7. 5 over 2, 0 plus 7. When you add that together, that equals 17.5. Let's say we did this all in centimeters, and it's going to be centimeters squared because we're dealing with area. Again, you do that to the same side. So we'll rub out this side here using the same formula. We go A equals, and we look at this. We notice that it's 1, 2, 3, 4, 5. So H is 5 over 2. DF, our first line, same as this one because we're starting in the middle. It's not here. It's starting from where you put it. So this one is going to be 7. And you go to the second one, notice that there's no number there, so it's 0. Again, put that in your calculator, and you get 17.5 centimeters squared. And if you add all of that up together, you get the total area, which is 35 centimeters squared. And that's how you would solve a question like this.